Recording in progress. All right, cool. Okay, evening everybody. So what I'm going to do for most of this is I will share my screen and pretty much everything will be on that. And we will go through, I've got some PowerPoint slides, and then mainly we'll be going through RASP on the website itself and actually looking at probably most of tomorrow's weather. So let me share my screen, or the other one.
If people have questions, do you want to put them up on the chat group?
Let me think. If they do that, I'm probably not going to see. If you could monitor it for me,
Yeah,
Robin.
I've got that open. So if there are any,
okay, and if they come through, and just let me know, and I'll stop at certain points and answer them. We'll do it on that basis. Cool. All right, here we go. So this is always about using RASP. So what does RASP mean? Bit of background data. RASP is a regional atmospheric soaring prediction. It was originally designed for sailplanes, not for paragliders. And the character called sort of Dr. Jack basically put the whole thing together originally. His own reference on it is useful to remember that it is a model. It is not a crystal ball. You know, the weather and the atmosphere are very complex things. So the best you can ever get is some sort of prediction and idea about what's happening. And RASP, that's what RASP gives you. It's simply a modeling system. It's not perfect. There are errors. And once you've got this basic introduction, really the way to get used to it is to look at RASP, look at the weather, look at RASP, look at the weather, and start getting your own idea of what works and what doesn't. So I won't get too technical about it, but essentially, yes, so RASP is something that gathers lots of data, juggles it around and presents it in a way that allows us to interpret things in an easier fashion than looking at complex charts. By the way, what I will do, the slides you're seeing, I will drop onto the forum afterwards as a PowerPoint, so that they'll be available to anybody after the meeting as well. Again, it's just a quick outline how RASP works, just the background data. It just downloads lots of information, and it then runs it through a program which analyzes the data, converts it into charts, and puts it up onto the website. You don't need to know too much about that, but it's just a bit of background as to how it works. I'm going to skip over that point for now. Updating. Unlike something like the Met Office or other weather platforms where you're getting regular updates, like if you check the Met every hour, it would have changed. RASP runs once a day, does all its updates. So once you've looked at it, once it's run and presented its data, that's it for the day. Checking it again every hour won't change anything because you've just got that fixed data there. So it's quite important to realize that once the run's done for that day, it's done, and you're looking at the prediction for that day, it then doesn't do another update till the following day. Okay, so I'm now going to basically kind of flip over to the website itself, and we'll look at that. In terms of getting onto it, this is the link here, http://rasp.stratus.org.uk. Now, I put this note at the bottom because it is an HTTP, not HTTPS. It's a slightly technical point, but most web browsers nowadays, if you just put in rasp.stratus.org.uk, will force it to a secure link and send it to HTTPS. The page will come up, but it doesn't run properly. You'll find the charts don't work, things don't occur. So just be careful when you go to it that you do use HTTP and not PS. So I'm going to flip to, I'm going to bring the actual browser up. And as you'll see at the top here, it says not secure because we're using an HTTP, not HTTPS.
John, can I make one comment.
Yeah.
It is worth opening this on your phone and saving it as a homepage on your screen so that you can access it when you're on the hill or when you're not in front of a desktop computer. And the layout may be a little bit different for mobile applications, but essentially it's the same.
You'll get the same web page. It's I'm gonna, yeah, I mean, by all means do that. Certainly bookmark it on your desktop. That's what I do. I have it bookmarked, so it goes straight to it. Anyway, so it's just the basic structure of it. So when you open it up, you'll see all these options. Now, what you might notice, if I narrow this down, this might be how it appears on your mobile. Basically, you'll notice the top menu vanishes and you get this gray drop-down button instead, which then lists everything out. So I suspect I've not tried it on a mobile, I suspect it will do the same thing.
Yeah, it looks familiar.
Yeah, it'll basically take out the top menu and give you this drop-down. It's exactly the same options, but it's just presented in a different way. So most of the time on a PC, you'll see this. When you'll see it's got Rast desktop and it's got Rast mobile. They both give you exactly the same information. Oddly, my preference is to use Rast mobile simply because on this, which is the desktop version, as you zoom in, it doesn't expand to the whole screen. So for me, this is a personal preference, I prefer to use this option where I can actually move around the screen. It just makes it easier for me to see. So, but it makes zero difference in terms of the options, choices, and what you get. But because that's my preference, I'm going to work on the mobile version because I just find it easier to see and stuff. What you'll notice at the top of the page, I'll just flip back to a slide for this, just to highlight it. This one. So at the top of each map, you'll get something like the above. It'll say whatever option you've chosen, doesn't have to say wind at 10 meters, but what it'll tell you underneath is when the forecast is valid for. So this is for Thursday, it's an 18-hour forecast, and it's a 2 kilometer resolution. So I'm just going to go back to just to flip back and explain that. Back up again. Right, so basically, if I just take you through these menus on the left here, the first one, the top one, gives you days, and you'll see the top bracket, you get an entire week's worth, and they're all 2 kilometers fine. So in other words, these are the higher resolution analysis. So what it does is let me go back one second. So then you've got medium, underneath you've got coarse. And so the fine is a 2K resolution, medium is 4K, coarse is 12K. And it's simply, when it's doing its calculations, it kind of divides the country up into squares. And so the 2K one, it's analyzing it and breaking it down to give you a 2 kilometer square picture. The 4K is a 4 kilometer square picture, 12K is a 12 kilometer square picture. So the 2K is obviously going to be the most accurate, but there is a slight exception to that rule, which is on the actual day. So if we look at today for Thursday, if I bring up the 2K one, so this is the 18-hour forecast. If I bring up the 4K one for today, it's a 12-hour forecast. So on the actual day, the medium resolution gets run 6 hours later than the fine one. So you're actually getting a more up-to-date prediction on the conditions. So my preference for looking for on the actual day is to use the 4K medium, It will give you, from my experience, the best predictions of what's occurring. So if we take a look at today, and we'll have a look at some of the options. Anyway, so hopefully that's fairly clear. Is you choose your day and you choose your resolution from this menu down the side. So we're going to do Thursday, UK, 4 kilometers, medium. The next drop down, what Rast does at this point is it says, okay, these are the most commonly used parameters that people have. So we're going to give you those we're going to take away the expand the list and give you these. Each of these, as you go through them, will change what you see on here. So let's just take let's take the surface wind at 10 meters. So and I'm going to change the time to start at 10 o'clock in the morning. So what we see here was the prediction for today, which was, so the pink lines are giving you wind direction. The coloring is giving you wind strength. And all the wind strengths in RASP are done in knots. So you'll need to convert that into either miles per hour, kilometers per hour, whatever unit you're working in. But as you can see, the forecast for today was very strong this morning. I mean, it'll be coming through, but sort of somewhere between, down here, it looks like going from blue to sort of somewhere between 12 to 16 knots, it looks like. If you click on the screen, you'll see it currently says 10 o'clock. If I click on it once, it moves it to 11. So you can actually, by just clicking on it, you can progress through the day to see how the wind is changing. So if we just zoom out just a little bit, so we can see here we're at 11. If I click on it again, we get the predicted wind strength at 12, 1 o'clock, 2 o'clock, 3 o'clock. Essentially what we can see is that this area that we're in, which is looking at probably, scroll right down. So the wind, it looks like it actually kind of almost probably picked up on the coast during the day. I wasn't there, I don't know. Inland, you can see it's dropped off quite considerably. Looking at the various site reports from the day, I would say this looks like a reasonably accurate representation of what was occurring, given that it was kind of like hang gliders only today. But let's whiz through a couple of these key things. So that's your surface wind. And we take it at 10 meters because it gives you your launch wind. It's kind of taken out the immediate ground friction that you get. The other thing we're interested in is, okay, that's the wind strength and direction. How thermic is it going to be? There are various options for this, but the simplest one is thermaling height. So if you have a look at the thermaling height, and again, that was by the end of the afternoon. If we go back to the beginning of the day, so basically it was predicting at the start of the day around here, probably about 1,000, somewhere between 1,000 and 1,500 feet. If we progress through the day, you'll see a couple of things happening. One, inland, you'll see the lift is going up. What you'll also notice is along the coast here, this progression where it's gone, the thermaling height is dropping. Now this will be basically sea air moving in. But if we take a look again, if we zoom in on what we're looking for, there's full. So it looks like it topped out. Here it's getting to about 2.5, probably catching the sea breeze. Now you can see it, sea breeze pushing in, and it's now come 2 o'clock. It's kind of killing it. Lift is gone, and they're probably, maybe they might get 1,000 feet out of that. And now 4 o'clock, 5 o'clock, it's going to be very, very bitty. And looking at some of the reports I saw from the hang glider pilots, that seems to be a reasonably accurate prediction of what occurred. So we're looking at this, but we're looking at an overview. It gives you a good overview of what's happening across the country. I'm just going to flip back to the start of the day again. The other one that a lot of people go for as a quick indication is the star rating. Now, what they've now added, the first star rating is for sailplanes. They've now added a star rating for foot launchers, which is what we are. So what it basically predicted was crap star. Basically, star rating of 0 means it's not very good. What we're looking for is 4 and 5s. As we go through the day, it basically kind of said, well, there wasn't a lot of point being in this area. Not a lot was going to happen. Do
you want to have a look at tomorrow for this, John?
I'm going to bring tomorrow up in a second. Okay. I'm going to bring it up in a sec. But in terms of, if you zoom out for the whole UK and go through this, you can see the area around sort of Wales, Malvern, that sort of area was probably, they had a much better star rating. There's probably guys that put flights in around that area. Out of interest, we'll go through tomorrow and we'll take a look at Saturday for those who are going to the BCC as well. So these are kind of your most common ones. Now, for those people thinking of going cross country, the other one that's actually useful is this one, which is the boundary layer average wind. What this basically does is it looks at, it does what it says. It averages out the wind vectors through the air mass you're flying in and gives a good average of what you can expect the wind strength and direction to be at the height you are flying, basically at a sort of cross-country height rather than hill height. It's very relevant in terms of if you're planning to go cross-country, then it's all well and good knowing that, yes, you can launch and what direction that's going to be. But in terms of where you're going to go, this is actually giving you a much better idea of the wind direction at that point. Now, as it happens for a lot of this, it's probably not significantly different in terms of wind direction. That's not uncommon, but it's certainly different in terms of strength. But it's always worth a check. So on some cross-country flights, I'll go back to again, sorry, the boundary layer average wind will actually be significantly different, and it'll be, oh, okay, so actually, rather than going south, I'm actually going to be going more sort of southwest or southeast or whatever happens the case. And it allows you to predict and plan for it. So this is very much a tool to help with cross-country planning. Couple of the points bar on this screen. This little option at the side here, you'll see it gives us 4 different things. It gives us soundings, which I'm not going to cover in this talk. Gliding sites, just shows you where main gain, but these are sailplane sites, so not too interested in those. Now, these last two though, the last one is airspace. So we'll actually overlay it with airspace. I think unless you're used to airspace and looking at airspace maps, it's confusing and you'll probably not really understand what's going on. So on here, I don't think it's the best tool in the world, but for those who have an understanding of airspace, got an airspace map and want to see how it overlays, then it's useful. What is useful for this, which we'll cover, you need to know about, we'll come back to this a bit later in the talk, is this one, BGA, the British Gliding Association term points. So these are all the preset term points that the sailplanes use.
John, I've got a question from Paul Hervé about the star rating and how it's calculated. I mean, I think the simple answer is low is bad and high is good. I'm not sure what the precise formulae are. But
on that, okay, what I'll do just to answer that question, I did skip over this, but I'll just go back to this earlier slide, which I've got. What I've got, okay. There is a complete list of all the parameters here that you come across. If I just pop it open, website block Judo. Won't go to that one. Right, not going to go there. If we go back to, obviously that, I'll remove that link if that's what it's doing. You can get, I'm just going to skip back one stage for this point, just to answer something. What you do have here, under help and frequently asked questions, are interpretation of RASP charts. If you come to this one, it will actually, I won't go into too much detail, but this link will give you a complete document which actually takes you through and explains all these different parameters in detail. Again, I'm not going to start going through all this, but for those who want a more technical explanation of things, that link is going to actually give you that data. That's more just so you know it's there. In terms of a star rating is essentially something that averages out the key factors, which are to do with wind strength, wind direction, thermaling height, cloud cover, and it basically predict on that basis. It goes, okay, this is going to be good, this will be bad. I'm going to show that to you a bit later in another chart, which will actually make it a lot clearer. You can see how where it comes from. But just going back to this briefly, the purpose of these term points is if you're looking at somewhere you're flying or a route, basically you can make a note of the turn points. You can go, okay, let's take a classic sort of dike cross country, and this one, so here we've got Devil's Dyke, DDK. We'll make a note, I think, DDK, Devil's Dyke. This one, we've now over here, we're going to go, this is, probably wouldn't go blind, maybe probably a bit too far, but I'd then probably take RIN, which is Ringmer, and HEE, Heathfield, etc. So I would make a note of those. And then if I'm getting really adventurous, I'd come over here, I'd probably take Ashford, not Canterbury even, Cap for Canterbury. We just note those down, and I'll show you, we're going to use those in the next bit. But basically this allows us to see which of these turn points are on our route or planned route that we can then use later. Okay, so those are the key ones. If you really want to get in depth, then you can switch to the full list, and there's a whole bunch of other ones on here. The key ones are in blue, the other ones are in black. My advice is not to do that at the beginning because it's just going to overwhelm you with information. Stick with the short list and just stick with these key ones of surface wind, thermaling height. Star rating is an easy one to look at. I wouldn't even right now get into, I mean, I put some notes on my thing about cloud base, overcast potential, things like that, but I wouldn't get too technical with it initially. My advice is when you're first getting used to it, just take those key ones of surface wind, surface wind and thermaling height will sort out most things for you and give you a good idea of what's going on. Okay, so before I go on to the next bit, so I will take, if anyone's got questions on this section, please ask and I'll answer as best I can. Anything popping up, Robin?
I've got a question from Kate. Do 5 stars mean that conditions are likely to be rough, i.e. should low airtime pilots avoid 4 and 5 star conditions? I'd say that the star rating indicates that it's likely to be a good XC day and it's likely to be thermic, but it doesn't mean avoid the hill completely because it will be less thermic and less turbulent at the beginning and end of the day. Yeah,
I mean, it's yeah, certainly star rating does not equate to turbulence on the hill. That's for sure. So it's so no. So the short answer is star rating does not mean don't turn up at the hill. Far from it. You can have a very low star rating day, and it is the worst day to turn up on the hill because there's no lift. It is rough. There's no separation on the hill, and it really isn't a good day to go to it, to be honest.
I know you're going to come on to it, but it's worth looking at the RASP by turn point.
I'm going to get onto that.
The likely conditions at a particular site. Yeah,
that's the next bit I'm going to basically go on to. So that's essentially that's your. I mean, that covers the basics of RASP without getting too technical. It really is. You choose your day, you choose your time, you choose your parameter, and you can flip through them. And I'll just take off the turn points because to make it look confusing. And yeah, you've got your chart down the side, which tells you strengths. And then as you get familiar with a couple of parameters, you can then add more. There's other things you can start looking at. But there is no point overwhelming yourself by looking at tons of information that doesn't make a lot of sense. So you take key things that will help you get in the air. Okay, so I think that's pretty much what I've covered a couple of other ones on here, which I've explained in the notes. But mainly they are thermal updraft velocity, height of critical. I have explained something about cloud base and cumulus potential for those who are, another one, Tom on his iPhone, who are interested. But this is really just explaining more of the parameters, and it's getting slightly more technical, but it will give you an overview of what the cloud base is going to be. And I remember, so before we go on to that, we change it. Robin said, look at tomorrow. So we're going to look at tomorrow.
I had one point here, John, really in relation to Kate, and it will come up in the RASP by turn point, and that's the thermal strength, which RASP shows in feet per minute. Most of us are more used to it in meters per second, and that will show how strong the thermals are likely to be at different times of the day, and gives you an indication of when it's very strong and therefore perhaps worthwhile to avoid.
I think we'll look at that. We'll certainly look at that shortly. We'll bring up the those information charts and we'll go through those, because I think they give you a good picture for the day of a site, which we'll get onto. So let's go back to RASP for tomorrow. So I've gone with the this is the medium prediction for tomorrow. We'll go back to the surface wind and we'll take it from 10 o'clock in the morning. So this is showing quite strong northeasterlies first thing. And if we flip through the, for our sites, if we flip through the day, see it dropping a bit by 11. Then it picks up again. So it's staying fairly constant, actually, in terms of wind strength through this area.
It's worth perhaps making the point, though, that RASP is based on one model.
Yeah.
And there are other models, particularly things like Windfinder that I've looked at today, which suggests that perhaps the wind strength might be a little less tomorrow.
As I said at the beginning, it's a forecast.
Yeah.
You're never going to know how valid it is unless you're on the hill to check it. So yes, this is, what RASP is excellent for is predicting thermic activity, which you're not going to get from the other ones. So by all means, look at other ones for wind strength. But if you're looking for a cross-country point of view and an overview, certainly for the free software, RASP is going to give you stuff that you're not going to get on other sites. Having said that, looking at tomorrow, if we look at the thermaling height, then what we see, I'll go back to 11 o'clock. If we go down to our sites. So we're basically looking here at, there's Firle, Alceston, Salmerston. So between Firle and Alceston is our sort of Bow Peak Ridge. And looking at that, first thing, 11 o'clock, we're saying, okay, you can expect, you know, climbs to about 2,000 feet. But what we can see here, pushing in on the edge, is the sea breeze. Go to 12 o'clock, it's actually looking quite good at that point, saying, well, okay, you're going to maybe get up to about 3,500 feet. And I suspect this is partly convergence and the sea breeze pushing in. Get to 1 o'clock, it's gone. Now that's interesting to see, because if we go back an hour, in the space of that, it's going from very lifty conditions. And we go 1 hour later, and that looks to me like a very strong sea breeze that's pushed in and taken out the lift. And some weird things happen. It actually comes back between 2 and 3 and then goes again. So it's not, I would say tomorrow is a weird day for lift. It's certainly a day to be cautious around lunchtime. Something happens then. I will just show you one other graph on this, which is this one, which is convergence. And if we take a little look at this, so this is convergence, is where you've got normally like, well, it's where two air masses are coming together and you're getting lift. And if we look at what's happening, 11 o'clock, this is convergence. You can see the convergence in this area around, you know, just to the north of Eastbourne. A lot of convergence here. Pushing in again, this is probably not, this is between Eastbourne and High and Over. It doesn't really, interesting, it doesn't really form. We don't really get, sometimes you'll get a very clear-cut convergence, which we're not getting. So it's not even giving us the benefit. Yeah. I think if you look at Saturday, we'll see a different picture. So I suspect that's kind of sea air coming in. We're not getting convergence. Based on that, when we'll look at another chart in a minute. We'll see what that shows. If we take a look briefly at Saturday, now Saturday's from a prediction point of view is quite far ahead. We'll just quickly flip to the star rating for Saturday and go back to, right, so for those of you thinking of Southeast Wales and stuff, you can see Southeast Wales has the nice star rating. This is where I think they're having the BCC at the weekend. But as the day progresses, it sort of builds along the coast here. So we would kind of expect to see, if we now take our surface wind, go back to the start of the day. So here on Saturday, it's predicting lightish northeasterly winds. That's quite good as we go through the day. It drops off as you come further west, and it looks like it's building. It gets again, you can see it's picking up a bit of strength around this area, but nothing serious. So it's a lightish day, which might be a disaster in terms of ridge soaring. In terms of thermaling height, again, let's go back to about 10 o'clock in the morning. So we've got, so by 10, it's predicting reasonable climbs to up to about a couple of thousand feet. Picking up in strength, 2.5 to 3,000. So in this area. So now we see, for those who are planning XC, you need to be away from this area by 12 o'clock and kind of over towards Glynde. And now you've really got to be hammering it because the sea breeze is pushing it, it's killing all the lift. And unless you're kind of far enough north, quite far north, I suspect pushing on the 4,500 line, you're not going to go anywhere. Now that's a prediction for Saturday based on yesterday. So that's kind of like it's a 50-hour forecast. I would expect that to change tomorrow and then on Saturday change again. You know, RASP becomes more, as you'd expect, more accurate the closer you get to the actual day, and on the day itself, it gives you the best prediction. So do bear in mind that you need to look on the morning to see what the final outcome is and be prepared to change any plans. But on the day itself, you will get the best forecast, which makes sense.
Also,
Okay.
sorry, John, I would say you've probably seen on Telegram that there is an event on at Bo Peep on Sunday, which means that Bo Peep Lane will be closed. And it also means that traffic around Firle will probably be a nightmare.
Yeah, I think the traffic might be, I don't think Bo Peep will be an issue. I'm pretty certain the wind, it looks to me like it's going more southerly by Sunday.
Okay.
So I don't think Bo Peep itself is an issue, but the traffic in the area will be an issue. So let's now go on to the next bit, which is, oops, wrong one. So now I'm going to look at, not look at that. We're going to look at these things. We're going to look at the Blip charts. Blip is boundary layer information prediction. And it's covered by this little thing called a Blip spot maker. And if I flip back to this, go back to the main heading, you'll see it here. It's called a Blip spot maker. And this is where you need your sort of your BGA term points. So Blip spot maker, pop it open, and you'll see here it's got select your BGA term point. So the nearest one we'll take Firle Beacon, which is FIB. FFFF. Where's it gone? FFF, FIB, Firle Beacon. And we're going to look at, let's take tomorrow at Firle. So you select that, you select the day, and you select generate. And what it does, it goes off and it comes back and it produces a whole bevy of charts. So we'll take the top one. As Robin said, it does everything. All the measurements are in feet here. The height is in feet. Now this gives you, as you can see, it gives you boundary layer top. The blue line, blue dash one is your thermaling height. The yellow one is height of critical updraft. And the gray line is cloud base, and the red is your thermal strength. So without particularly getting into figures, what we can see is you can see the thermal strength peaking at 12, dropping off steadily during the day. So as we would expect, midday thermal strength is its strongest. It's predicting thermal height of just under about 3,000 feet. And that would take us up almost to cloud base. So we can see from this the progression through the day of how strong the thermals are going to be and our expected thermaling height and how long it's going to go on for.
Just a word on the thermal strength. 500 feet per minute is basically the same as 2.5 meters per second. Anything above that is quite lively.
Yeah, I mean, if you're not used to it, even 2 meters per second will seem lively for those who have not experienced it. But certainly if it's more than, as Robin says, as soon as you get into like 4 meters, 5 meters per second, you're probably pushing things a bit. We won't worry too much about surface temperature and dew point, but we will go to this one, which gives us the surface wind, wind speed. So here we can see the progression of the wind speed during the day. And what we can see is that it drops a bit at lunchtime, and then it steadily picks up, not to enormous amounts, but it's slowly increasing for the rest of the afternoon. And the wind direction, interestingly, it doesn't change much for the whole day. So per this, it's just staying on the hill pretty much all day. I'm going to give you a comparison to that for Saturday, and so you can see a difference. The other ones I wouldn't. Oh, okay. Here's your star rating. So this, once you can see the graphs above, you can kind of see where the star rating is coming from. So the best star rating is around midday, between 11:30 and 12:30, and it hits at, it's giving it a 2.5 star rating. So it's kind of okay. If we look at what's happening around that time, we come back up to these ones between sort of 11:30, 12. This band. So I should have it wrong, but you can see you've got 11:30 there, 12:30 there. So you've got your best thermaling height, you've got your strongest thermal strength, which kind of makes sense.
While we're on this screen, John,
yes.
The graph below relating to temperature, not so much at this time of year, but early in the year, that's quite useful as a predictor of fog and mist, because when the surface temperature is below the dew point, that's when that occurs.
Yeah, because then everything's automatically condensing because it's already at, the air's already at.
People being aware of that, it's probably about the one thing that you can learn from that graph.
Yeah, otherwise it's, I don't think you can do much with it. I think on this page, the key ones are the red line for your thermal strength, the blue line for your thermaling height, your red line here for your surface, well, both lines there, because actually it's useful to know, is there a big difference between the surface wind and the upper wind? Here there's not, which means it's going to be, wind strength is not going to suddenly change as you get higher. If there's a big difference, it means at some point you're going to hit possibly a wind shear, and as you get towards the top of a climb, it can get very rough. But this is because there's not a huge difference in the wind strength, then it's not a massive change of wind as you go up. Wind direction is the other good one, key one to look at. As a comparison, I'm just going to bring up Saturday for this. So here we see that something very odd happens around sort of between 3 and 4 o'clock on the thermaling height. It suddenly goes to almost to nothing and then picks back up again.
Sometimes RASP does that though. Sometimes RASP comes up with graphs which
it does.
It's not easy to explain and may well be wrong. And
it's nothing. It's part because there's nothing kind of obvious as to why it's doing it. The wind hasn't suddenly changed. It's not significantly changed direction, but it does. What you can see here, though, is it does clearly go much more easterly. It's northeast, northeast. It changes, and now we've got an easterly wind coming through. So it's possible. I suspect this later blip. It's probably it might be a bit of convergence it's trying to predict. I don't know, but it's definitely an odd factor in there. And I think if you anyway, so these are the key. We've got again too significant about that. So these are very useful to do. Now, one of the things is if you're playing cross country, what you can do is look at these on a route. So, for example, if you were going, let's take Saturday. So you're starting off in this area around Firle. We can see it doesn't look great. you know, we've got a base about 2.5 grand to get away with. If we look further along the line, if we take Ditchling Beacon, do that for Saturday. So now, oops, what we can see is basically something's happening at 2 o'clock, clearly, because it just, the lift all goes on the blue line. But we now got, whereas a bit further, we were sort of topping out about 2.5. Here, we're getting sort of 3 to 3,500 with our thermaling height. So it's a bit stronger inland. There's also around this point, something slightly odd happens with, like, the surface wind gets stronger than the upper wind. So this looks like there's some lower wind that's coming through. And when we look at here, what we see is a definite sea breeze effect, which kind of ties in with this wind speed change. So the wind is like northeasterly, starting to go east, then here it suddenly switches. So now we've got a distinct southerly wind coming through. And that's going to be a sea breeze coming in around that time.
We've got another question up here from Kate. Very useful information. Can you recommend some turn points that are relevant to our sites to the Blip spot maker?
Yes.
Well, Beacon is pretty obvious, but which others should we look at? I'll put something on the coaching group for.
Yeah, well, what I'll, to answer that as well, what I'll do, if we just flip back, if we go to this chart.
There's the map one that shows.
Go to the map. If you go to this on the side, you bring up the BGA turn points, zoom in. We then take, you can basically then just click on to see what they are. So near us, you've got, for High and Over, you've got Alfriston, because High and Over is there, or AFP.
We've also got Seaford East.
That's, yeah, I mean, that's probably not a lot of use to us, I would have thought. It's questionable. Certainly for, this is High and Over, you always got Firle Beacon, you've got Glynde for Cavan, GDE. You've got, that's Lewis, oh, it's really kind of flying XC, but it's Lewis North. We don't have a site there, but it's obviously between Glynde and Ditchling. So if you're looking at this whole ridge and a flow through, you can see it. I mean, these are more for local sites. For cross country, then you'd expand out, but you can see clearly, Devil's Dyke is DDK and Truly is TRU. So we've actually got turn points on Truly, Devil's Dyke, Ditchling, Glynde, Firle Beacon, Alfriston. That covers most of our sites. As soon as you're planning some sort of cross country, then you just look at, yeah, standard cross country route from like Devil's Dyke would be going out this way. So you might look at Battle, Rye possibly.
It's perhaps worth saying, John, that for cliff sites like New Haven and Beachy Head, this is really less useful because you're not relying on sea breeze. The air's coming off the sea as colder laminar air.
It's yeah, no, forget it. Don't use this for predicting what's happening at New Haven or Eastport. It's not designed for that. It is, you know, the purpose of this is for soaring prediction for sailplanes. That was its original feature. So there, and then when you look at these, are all like the turn points that the sailplanes are using. This is, they'll plan routes on this, you know, up and down the country. So it's not, it's going to tell you very little about coastal soaring. It's used, in fact, I think I would go as far as say it's use this for coastal soaring predictions. Don't use it for coastal stuff at all. Basically, its major tool is for showing you what's happening out of sight, planning cross-country flying, giving you an idea of conditions throughout the day on the more inland sites. Anyway, hopefully that answers on the BJ turn point. I would just simply go to this map, find what you want, put your mouse over it, note it down, and then you've got those that you can use to plot your day out. So I'll just go back to, covered that, turn points. Sorry, that's my this one back up. Okay, so just as a comparison, if we take, and they're planning what, so BCC at the weekend, if anyone's looking at going to Southeast Wales, what's the nearest one to Tally Pond? I don't think there's a, I don't think there's one that's really close to Tally Pond. Is going to be, sorry, zoom out a bit. There's Merthyr.
Beneath.
That one, I guess. There's nothing lower down. They don't have a lot, weirdly, a lot of turn points there. That's, I think, probably about the closest one to it. Okay, yeah, you're a bit. Okay, they don't have a lot of turn points for Wales, surprisingly, or maybe not. I don't know. I don't know why they don't. I'm not a sailplaner, but so I don't think that's quite as useful as where we are, where there's tons of them. There's Abergavenny, Crickhowell, but you're not flying in the area, are you? So. Okay, I can't. Okay, ignore that. I thought there might be a turn point close to where the stuff was happening on the weekend, but I can't find one. We'll ignore that one. Sorry about that small diversion. That didn't pay off at all. All right, I think at this point we've cut. I mean, those are really the basic features that will get you using RASP, take you through stuff. What I'm going to do is stop sharing, bring people back up, and then basically throw it open for any. So if people want to ask questions, you can. I think it's easy. You can unmute yourself and ask. And we'll take it from there. Anything? Any takers?
Yes, that was really useful, thank you.
Yeah, cool.
That's right.
No problem. Kevin, you have a question?
Sorry, I was going to think, why are they called turn points? Yeah, do they actually turn at them or?
No, because yes, when you're plotting planning a route cross country, you put turn points in. You go, I'm going to go from this point to this point to this point. Inevitably, it's not always a straight line, so there'll be some turning occurring. Or literally, the sailplanes, they're more likely to do out and returns. They're going to fly out to a point, come back and come back again. You know, they have their glide ratio is so different to ours. You know, you're talking, I don't know what, 50, 60 to 1 glide ratio as opposed to our 8 to 9 glide ratio. And you're talking an airspeed of, what, Ryan, 120, 150 kilometers an hour or something? Or
and their retrieves are a lot more difficult.
Yeah. So inevitably they will plan to fly out on a route, turn and come back. So they are literally turn points. So they'll program them in. It'll be okay. Here's my route. This is what I'm doing, and they'll use them for tasks, competitions, all sorts of things.
But what's special about those actual points on the map? Is there a piece of equipment there which is measuring some atmospheric?
Oh no. They're just. To be honest, I'm not a sailplane. I don't know why they've taken those. I suspect they're common landmarks.
I think they're recognizable from the air at the altitudes that sailplanes fly.
Yeah. I mean, it's, you know, historically, before we had like accurate GPS and everything else, if you were doing a competition, you would take a camera and you would photograph various points to prove that you reached that point. and I don't know. As I say, I don't know the history of turn points. Don't really turn this into a lesson on turn points. But if someone cares to find out, you'll probably find historically, it's, as Robin says, there are key landmarks there which identified where to turn. But there is no special significance. You're not going to fly over some radio and transmitter. There's no tracking device that's going to tell you you're there. Literally, they're just locations on a map that we use to get graphs and other information back. All right. Anything else at all with RASP you want to know? I mean, let's say it's a fairly basic introduction. I've made a mistake for making the introduction too complex and losing people halfway through it, so I haven't done that. What we can do is another day where we go into the more technical sides of it. Once you've had a chance to use it, get familiar with it, and play around with it. But do compare it. Like, look at the Met, look at some other forecasts, see how it compares to this. What you'll tend to find is, 4 or 5 days ahead, RASP is just a prediction. It's not even something you're necessarily going to base a day off on. 3 days ahead, you're kind of thinking, okay, maybe I should book some time off work. The day before, it's kind of like, yeah, okay, this is looking good. And on the day itself, everything can change, sometimes does. And it's not unusual for us to have planned something the night before, on the morning, look at RASP and go, nope, we're not going to go to Bo Peep. We're going to go to, some site in Thames Valley, or go to the Baldwins, or go somewhere else entirely different, because it's just changed overnight and it's now more favorable for going elsewhere. What I will say is that, the pilots who do consistently good cross countries use RASP. They will plan, they will look at it, it gives them their prediction, they'll plan their route based on it, and it works. So, but you have to try it for yourself. I mean, as I say, it's something you look at, you play around with, and it'll give you more understanding of what's actually happening on the day.
John, I have a question, but it's not a question for you. I see we've got Ben Gallagher here. How did it go in the Marathon des Sables, Ben?
Just before you get into that, I'm going to stop. If there's no more questions, I'm just going to stop the recording.
Yeah, fair enough.
We can chat. Give me 2 secs.